Okay, in this session, we will see the different types of CAD softwares. In the last session, I told with you different types of CAD models. It may be a 2D CAD model, it can be wireframe model, it can be surface model, it can be solid model. 2D CAD model means it is composed with the two dimensions. Okay, then wireframe model means the object which is described using the edges. Edges can be line or the arc. Then surface model means the model looks like a realistic model, but it is described or framed using the surfaces. So that type of model is called the surface model. Then when it comes to the solid model or 3D CAD model, um, it is exactly the realistic model. So for that we are going to assign the mechanical properties or the physical properties, like not mechanical properties, physical properties like the weight, density. So all those properties you can assign and you can calculate. So that is the realistic model for which we can assign the properties. So physical properties of the materials. So now let us come back to the types of softwares, CAD softwares. So the basic software that you are fully aware is AutoCAD. AutoCAD is actually it is released in the market around 1982. It is released in the market around 1982. So making it very established CAD software across all the industries. That means the basic software is AutoCAD. Now also most of the industries will use this AutoCAD software to draw the basic level drawings. This AutoCAD software is basically used for the two-dimensional drawings. It is not preferred to draw or to generate the three-dimensional drawings. So as I said, this AutoCAD software, by using this AutoCAD software, it is not possible to create the complicated three-dimensional drawings. You cannot generate complicated non-uniform surfaces, B-spline surfaces you cannot create. Simple three-dimensional drawings you can generate using the AutoCAD. Regular shapes like the cube, rectangle, sphere, toroid, simple toroid, all those you can generate directly. Wedge you can create. So this AutoCAD is used for this purpose, basic drawings. Then when it comes to the ThinkerCAD and FreeCAD, ThinkerCAD is an online 3D design app. Okay, so this is for the beginners. Basically, ThinkerCAD and FreeCAD is for the beginners. It is also from the Autodesk. So this AutoCAD is also developed by the Autodesk. Autodesk is one of the commercial software industry. So though they are going to develop the softwares, AutoCAD softwares are the mechanical design related softwares, Autodesk. Okay, so this AutoCAD is also developed by Autodesk, and as well as the ThinkerCAD and FreeCAD. Both are also just like Paint. You might have seen Paint, how it looks like. This ThinkerCAD and FreeCAD is just like Painter. If you want to create simple drawings, simple 3D models, you can create using the ThinkerCAD and FreeCAD. Okay, so basic shape, as I shared with you, these softwares will allow you to develop models, basic level models from a set of the basic shapes. So this ThinkerCAD and FreeCAD is having some library. So that library means space where all the shapes are stored, and from that place you are going to pick the basic shapes and picking and dropping, just like. So that is called, 1 minute, Andy. So this is about the ThinkerCAD and FreeCAD. Okay, so these are basic level softwares like Paint. So most of the children will play with the Paint, simple drawings. So it is like a Paint. Okay, so let me move further to discuss the other softwares. So very important softwares. So PTC Creo. PTC Creo is PTC is Parametric Technology Corporation. So PTC stands for Parametric Technology Corporation. So it is established more than 30 years back. So Creo and Pro-E, Pro Engineer. Pro-E stands for Pro Engineer. So PTC Software, PTC is the company, but PTC Creo is one software, advanced software, now commercially available in the market. So this Creo software is used for generating the 3D models, 3D components, mechanical components. Basically, this software is meant to generate the mechanical components, 3D components, complicated components. This is one software, Creo, and before Creo software, the other version is Pro Engineer. Pro Engineer is before this Creo software. Creo is advanced software now available in the market. Okay, so this is going to integrate many functionalities such as thermal, structural, motion, parametric, and freestyle surface generation. Freestyle surface generation means, as I said, you can also generate the advanced surfaces like the B-spline. So B-spline surfaces are the advanced surfaces on which the coordinate values varies from point to point. X, Y, Z coordinate values continuously varies from point to point. So that type of surface is called B-spline surfaces. Like you take the blades of the turbine, you take the blades of the, or you take the aerofoil shapes, or you take the runner blades. The coordinates of the runner blades, turbine blades also continuously varies from point to point. So those type of surfaces are called the freestyle surfaces or advanced surfaces or the B-spline surfaces. So those surfaces can be generated using this Creo software. Along with that, you can also have the functionalities such as thermal, structural motion, even you can animate some extent. But I would like to remind you that Creo is not analysis software. It is only the 3D modeling software. You cannot analyze that. Okay. So it is having the functionality, thermal, structural motion, some extent. Okay. So parametric and freestyle surface. Parametric means continuously its parameters varies. So those type of surfaces you can generate using the Creo software. So it is complete tool are ideal for additive manufacturing. Additive manufacturing means already you have some 3D printing. Additive manufacturing is just like a 3D printing. So where I mean seamless joints can be generated. So without you might have seen 3D printing means this is advanced technology now. 3D printing. Okay. So example, you have a shell and inside the shell you have one bar. So how do you generate that? How do you machine that? So those type of components can be generated in additive manufacturing. The best example for the additive manufacturing is 3D printing, three-dimensional printing. So the machines are available. Advanced 3D printers are available in the market. Even you can use the molten metal to generate the component. Okay, so where the machining is very complex. There are some components so on which it is not possible to machine. So those components will be manufactured using the additive manufacturing or 3D printing. So you may have a doubt that so where do we use this additive manufacturing and 3D printing? 3D printing is having some limited scope. This is used where the complexity is high. So where the components complexity is high and those components which cannot be manufactured using the conventional methods like the machining process, like the casting process. So in other conventional machining process, so I mean which are not possible, those components can be manufactured using the additive manufacturing. As of now, you remember that additive manufacturing means 3D printing. Okay, so that allows you to perform all your dimensioning calculations while modeling your final idea. Okay, so even which gives us all the dimensions. This is one of the best software commercially available in the market now. It is advanced version. It is developed by PTC, Parametric Technology Corporation. Creo is the software and the advanced version of Pro Engineer software. Okay, as of now you remember up to here. So next you take the Fusion 360. Fusion 360 is developed by Autodesk. Autodesk is the old company, as I said just now. ThinkerCAD, FreeCAD, AutoCAD is developed by Autodesk, and similarly Autodesk is Fusion 360 is also developed by Autodesk company. So Fusion 360 is a cloud-based 3D CAD model. Cloud-based 3D CAD model means, cloud-based means, so there is one server on which we are going to load all the software, and from there we are going to use. That is the cloud-based technology. Cloud-based technology means, so we have one server. Instead of purchasing software individually, we will take license of the software, one license of the software, and we will store that software. We will install that software in one system. We will use that software. Multi-users can use that software. So using the cloud technology. Cloud technology means it is a technology which allows to use the multiple people at the same time. So that is called the cloud-based technology. So 3D CAD, cloud-based 3D CAD program. So somewhere you can install the program, you install this software, you can use that software by sitting somewhere else across the globe. So that is called the cloud-based 3D CAD program. So this Fusion 360 is cloud-based 3D CAD program. So it is unique in sense that it uses the power of the cloud. Yes, as I said with you, it is having the unique power. It is cloud-based. Teams to collaborate on complex projects. As I said just now, it can be installed somewhere, and that software can be used by the multiple people. That's way it is very much flexible. Okay, so the advantage of this Fusion 360 platform is that it stores the entire history of the model. Entire history of the model means, for example, you are creating one model, screw jack you are creating. So to create screw jack, you have number of steps. First, you are created one rectangle, then you are created threads, then you are created bolt and nut, and you have all these steps, right? So those steps can also be stored in Fusion 360. In Fusion 360, all the steps will be stored as the history. Of course, in the Creo also it is possible. You can also see all the steps of the creation. The history of the component can be seen or stored in the software. So that is the flexibility of the Autodesk. Even the Creo also, this feature is available. Of course, it is not mentioned there, but in Creo also, while creating the component, so the steps used will also be stored in the history. That is also available in the Creo and as well as Autodesk also. Okay, so while creating a component, you are following some steps. Those steps will be stored as the history in the case of Creo and in the case of Autodesk. Autodesk is purely cloud-based technology. It works on the cloud-based technology or the platform. Cloud-based means, as I said just now, it can be stored somewhere else. It can be used by multiple people sitting across the globe. Okay, so that is the cloud-based technology. It contains the numerous design options, including the free form. As I said just now, you can also create the advanced surfaces, solid and mesh modeling. Of course, even in the Creo also mesh modeling is optional. You can also generate. Then Solidworks is also one of the solid modeling software published by Dassault System. Dassault is one software company which is developed. Solidworks is developed by Dassault System. It is often used by the professional 3D designers. Of course, Creo and Autodesk Fusion 360 is also used by the professionals. Of course, this SolidWorks will also used by the professionals, and all these are used by the professionals. Creo, Fusion 360, SolidWorks will be used by the professionals. So professionals means, of course, these softwares nowadays, these softwares are also available into academic version and commercial version. In the commercial version, there are number of options, whereas the academic version, we have less options like that. So these companies nowadays are releasing academic versions and as well as the commercial versions. Commercial versions can be used to develop the projects, whereas the academic versions, like if we purchase the component at the SolidWorks, so that will become the academic version. The company will sell as academic version, not the commercial version, because the commercial version is having some more extra features. So that is what the difference between academic version and the commercial version. So nowadays the software companies are releasing like that. So that is best option for us, because institutes are not going to go beyond that limit. So that is what the advantage. So one of the special features of this is that unlike much other softwares, so mimic curves, so gently inclining that the structure SolidWorks uses system of the nerves. Nerves means every component. The meaning of this component is that every line, even you create the line, even you create the circle, the system is going to generate an equation, nerves equation. Every line, every drawing, every entity, whatever you are going to draw on the screen will be in the form of nerves. Nerves is having specific equation. Everything is having some equation. So in other terms, I will tell you that everything, whatever you are going to create on the screen is in the form of mathematical model. So in other words, you can tell like that. Even you create a straight line also you can represent as an equation, right? Ax plus by plus c is an equation. Like that, even you draw the circle also, x square plus y square is equal to 0. Like that, r square, x square plus y square is equal to r square is the equation for the circle. So this SolidWorks software is going to create entities, every entity in the mathematical model. That is what he is trying to explain. So one advantage of this software is that a limited ability to import the STL files. So okay, this is having, so one disadvantage of this software is you cannot create STL file, stereolithography file. STL stands for stereolithography file. File is basically used for 3D printing. So almost all the 3D printers available now is going to work with the STL file. STL file means it is a neutral format file. After creating the model, after generating the 3D model, so directly you cannot integrate that CAD model with the machine, right? You have to convert that into the neutral format file. The file which is going to carry all the data related to that model is called the neutral format file. In the last class, I told with you there are number of neutral format files like STL, IGS, step file, standard for exchange of product model data file, IGS file, initial graphic exchange specification file, STL file. So these are all the files, neutral format files that you can convert uh, after generating the 3D model. So this STL file cannot be generated in SolidWorks software. That is the one disadvantage. Now you have other software, that is a Catia software. The Catia is also one of the powerful tools to generate the 3D CAD models. So it is also from the Dassault Aviation own needs. So this Catia software is developed for their own needs, because Dassault is one of the company, as I said with you, SolidWorks was developed by the Dassault, and as well as Catia is also developed by the Dassault company, but for their own needs, for their company. So they have the aviation company. So they are going to they are going to take up the projects commercially. So for their purpose, they are developed this Catia software. Okay. So it is powered by the 3D experience platform. So everything you can see in the 3D experience platform. That means, of course, the previous softwares, like as we are discussed now also, those are also 3D experienced software, but this is also 3D experienced software. Of course, he's highlighting that, but they are not highlighted. Everything, Fusion 360, Creo, SolidWorks, Catia, and all these are 3D experienced platforms. You feel that you are working, you are visualizing the 3D CAD model, isn't it? Okay. So even you can see the texture, even you can change the texture of the component, okay, while assigning the properties, material type, and the properties, physical properties. It looks like the real component. So original component when you see outside. So you should feel in that way. That is what uh, the meaning of this sentence. It is more than simple CAD software, of course. It is also a multi-platform software suited for CAD, CAM. Some extent, it is also used for the computer-aided manufacturing. Of course, manufacturing means we are not going to code using this Catia software. Catia software is not at all used for programming purpose. Don't think otherwise. Computer aided manufacturing means basically we are going to look into the manufacturing production side, but in this case this Catia is not used for the programming. Some extent like process planning, some extent like to identify the features. In the last class I told with you, feature means the region where the manufacturing will be focused. For example, hole is one feature, blind hole is one feature, slot is one feature, Okay, so where the region where we have significance towards manufacturing, that is called the feature. Okay, blind hole is one feature, hole is feature, slot is feature. So we are more concerned to produce that shape, right? So that is called feature. The region where we have significance towards manufacturing is called the feature. Okay. So now, so features can be identified using this Catia software. That's what he is trying to tell. So, some extent, this Catia software can also be used for the manufacturing side. And computer-aided engineering means not complete analysis. Some extent, you can see the analysis part, very less part, not much analysis part. You can't see the animation part, you can't apply the torque, you can't apply the power. The analysis includes all, right? So that you cannot go beyond the analysis software. Some extent you can analyze the part. That is what the meaning of that sentence. Now you have the OpenCAD is one software. It is free software application for creating the solid 3D CAD objects. Script-based model. It is a script-based model that uses the own description language. Okay, so they have written their own description language. So based on the script, the model will be generated whenever you instruct. So to develop the model, you have to write the script. That is what. Not like the pick and drop like uh, AutoCAD, then Creo, Fusion, Solidworks. So it is having script based. So to generate the entity, you have use the script, right? So this is what the concept of the OpenCAD. Okay, so it is interactively selected for modified by the mouse in 3D view. Of course, everywhere we use the mouse. OpenCAD script specify the geometric primitives such as the spheres, boxes, cylinders, right? As I said just now. So you have the script, you have to select the script and modify the script as per your requirement to generate the primitives. Okay, primitives means the shapes, okay, such as the spheres, boxes, cylinders, and it defines how they are modified and combined. Okay, so the script is going to define everything, right? You are taking the script and you are modifying because it tells everything for us. So this is what the OpenCAD. Then you have the Reno. So Reno Creo is typically abbreviated Reno or Reno 3D, is a commercial 3D computer graphics and computer aided design software. Of course, all these are computer aided design softwares, application software. It is developed by Robert McNeil and Associates, an American. So don't try to remember the scientist names. Of course, this Reno is a software typically abbreviated as Reno 3D, and it is a commercially 3D computer graphics software, and all these are graphics software. Everything is a graphics software, not only this. Okay, so Reno creates geometry is based on the nerves mathematical model. Of course, this is also going to create the entities on the screen by generating the mathematical model. Everything, whatever you create on the screen is or will be based on the mathematical model. So this is what the Reno. Okay, then when it comes to the features of the CAD software, features, this is very important. So these all softwares must have this simple in its simple to use. So it must have the simplicity that should be very easy to use. Okay, simplicity means it must be user friendly, right? So it must be very easy to use. That is called simplicity. All the softwares must have the feature that it should be able to use very easily, and it should be very user interactive. That is called the simplicity. Then it must have consistency. The package should operate consistently and predictably to the user, right? So it must be able to use consistently, right? Means without any errors. We must be able to use that consistently. Okay, so consistency means without any deviation. So it should be able to work properly. Okay, with respect to the time, it should be able to give us proper output. Once you execute the program, it gives us one output. Once you generate it, it behaves differently. So that is not called the inconsistency. That is called inconsistency. If it gives us consistent results, if it gives us the proper results or the same results at any time, so that is called consistency. Okay, so for example, if you get same marks in 10th class, if you get 90 marks, 90%. Even diploma, if you get 90%, even engineering, you get 90%. So that is called consistency. So this software must also work, must have the feature of consistency. Then it must be completeness. So there should be no errors. It should not give us any error. Okay, in set of graphic functions, right? It must be robustness. It should be very rough to use. Okay, that is called the robustness. It must performance should be high. Okay, uh, then it must be economical to use. That means it must be affordable to purchase. So that is called economy. So it must be have the simplicity. It must have the consistency, completeness, robustness, performance, and it must be economical to purchase. So these are all the features of the CAD softwares. Okay, but when it comes to the computer networks, okay, I don't have time now, and I have only 2 minutes, so I will discuss the computer communication networks in the next class. Okay, I will stop the session here now. So thank you one and all, and